My name's Andrew Hay. Formerly the Chief Evangelist at CloudPassage. I've moved into more of a research role with a title that's a little less embarrassing. I'm the Director of Applied Security Research. So today what we're going to talk about is fluffy forensics. Alliteration aside, this is something that really does interest me quite a bit, especially with a lot of people moving towards public, hybrid, private cloud environments. And as with any architecture, security is kind of a lagging concern. Forensics even more so. So this is the very quick overview of what we're going to talk about. How many people in here do forensics incident response on a day-to-day basis? Wow. Come on, Craig, you kind of do. Not day-to-day. Who here has ever done it before? Hey, that's better. All right, we'll go with that. So, traditional forensics and incident response. This is a very common workflow that people are used to seeing. And this comes from NIST 886. This is one of those, seminal works that you're kind of, if you ever ask, how do I get into forensics? How do I get into incident response? People usually say, oh, go read this document. And that'll keep you busy for, several hours and multiple paper cuts. With the collection, examination, analysis, and reporting, underneath that we do have examples here. So the media collection, data examination, information analysis, evidence reporting. We can actually simplify this. I don't know who did this on Wikipedia, but they did simplify it quite nicely into acquisition, analysis, and reporting. Why make it more complex than it has to be? And as with any process, we really should be tuning and refining and feeding it back into itself so we can refine our methods, our tools, our techniques, and make this a much more repeatable and easier thing to do. So just, again, 10,000-foot view. I'm not going to go through like forensic basics here because, well, like I was saying, we can't start the next session until I'm down there, so we could just do this for a couple hours if no one really has anything else to do. For the imaging, where when we're talking about acquisition, we're talking about getting the data. So that could be from a physical partition, dev HDA on your first IDE drive, logical partition, so D:\\, C:\\, even secondary partitions, ISO files, or any sort of like DMG file, anything that's an archive, or folders and contents of folders. So these are all pieces of data that you can acquire for a forensic investigation. Now, when we get into analysis, this is where it gets a little bit more complex. Acquiring data, very easy to do. Analyzing it, not so much. So who recognizes this, or these items? Where did the puzzle come from? A collection of the Windows registry and just Windows files, so ntuser.dat, for example. Who here knew that through looking at a captured Windows image file, you could actually determine whether someone physically typed in a URL versus a piece of malware inserting a URL? Anyone not know that? It's kind of cool, actually, when you think about it. So that whole Trojan defense thing doesn't really work all the time anymore, because that's the first thing people look at. So there's a lot of information, and this is just Windows. So also there's volatile pieces. So these are known as static analysis components. So things that happen once the OS version, your OS version is not going to dynamically adjust. But volatile pieces of information such as what's present in memory, what is executing, any sort of browser data. So browser history, that is going to keep incrementing as people browse around. That is known as volatile information. Any user-specific data or user-generated data would be volatile in nature. Reporting tools. Does anyone here have any, in their organization, do they know of if they have any enterprise forensics tools like access data, guidance software, in case, anything like that? They're very expensive, very good at what they do, but you still really, they're very complex, so you have to know how to use them. There are open source alternatives like the SANS SIFT kit. If you want to start learning about forensics, I highly recommend downloading the SANS SIFT kit. because it really does give you all the tools you need to acquire, analyze, and produce reports on your information. Log management tools. Anyone here have a SIM or log management tool at home or in their office? Yeah. They are a wealth of information. Actually, I come from the SIM space, as does Craig. We both worked at Q1 Labs back in the day. So I'm a big fan of log management and log information for forensic activities. Then there's the poor people tools. When I worked at a university, these were my powerful tools: VI, Notepad, Excel. Didn't cost that much. And this is, for the most part, there are a lot of people that do the majority of their forensic analysis using text editors or sedoc, grep, cat. They're just doing things on the command line because it's easier for them to use. So now that you all know forensics, any questions on those items at all? No. So these are very well-known pieces of just incident response and forensics of a system. Generally, though, they're applicable to static workstations, servers, mobile devices that are present and are tangible in your hands. You can go to your data center and point at a server and saying, I know that this has the information I need. I can either take it out of commission, or I can take the hard drive out. I can physically image it. I know exactly where it is should someone ask me. You can't really say the same thing for cloud, especially with the different types of cloud. Now, whenever someone says cloud, especially in California, because every company is a cloud company, they always say, well, what's your definition of cloud? Is it private, public, hybrid, where it spans both, SaaS, PaaS, IaaS, or, there's SecAS. If you just add AS to the end of it, apparently it's like a new fancy cloud term. You get your own magic quadrant. Is it on-prem, off-site, hosted? Who here runs VMware in their infrastructure? Just VMware ESX, for example. Do you consider that a private cloud? Aha! VMware marketing does. So there are certain criteria that make up what an actual cloud is, but again, I'm not really going to get into that either. But single tenant, multi-tenant, are you the sole user of your cloud infrastructure, or are you using a public infrastructure like Amazon where it's multi-tenant? Anyone can sign up with a credit card. Now, we could go endlessly on the different types of clouds. Security as a service, actually a lot of the cloud models have clear delineations of responsibility between the provider and the end user, the end consumer of that cloud technology. Am I getting feedback here? Move that down a little bit. Security as a service. Look at how much data. You have access to all that. You're responsible for all that. Isn't that great? As a forensic or incident responder, is it great to have a little bit of information? Probably not. When you go to platform as a service, you have that much more. Awesome. You are really relying on your provider for the majority of everything from the application code down to the physical, so plugs to code, and here, pretty much anything that isn't your data that you or your customer generates is the responsibility of the provider. Infrastructure as a service, however, is probably the closest thing to having your own physical server. It's more akin to physical server. But you have to think of it in terms of, okay, well, I don't own the facilities anymore. And this is the case of like public information or public infrastructure as a service. If this is a private cloud, you likely own this as well. But from the plugs up to the hypervisor. So this is your VMware kernel, your Citrix, all of those hypervisor. From the virtual machine, it becomes a container. You're responsible for the virtual machine all the way up to the user presentation. That is your problem. And Amazon, as does all of the other cloud providers, they go out of their way to say things like, they're very careful about the words they choose, such as customers should assume responsibility and management. It's possible for customers to enhance security with the addition of host-based firewalls, host-based intrusion detection prevention, encryption, and key management. They're not going to provide this for you. The cloud providers are not in the business of securing your stuff. They're in the business of providing you compute resources in order to get stuff done. It's far easier to do that than it is to secure it and give you the access to deploy it. So these are what I've identified as the 5 major challenges of doing cloud forensics and incident response. And if you've done any, is anyone here in any stage of researching or implementing cloud in any way, shape, or form for their organization? Yeah. So if you've done some research, you end up down a rabbit hole because not everyone's going to tell you everything you need to know. The providers all have different language. So these are very common issues that are applicable not just for forensics, but for the storing and curation of your data. So data residence definitely being the first one. Who remembers this video game? Yeah, So it's funny, when I first gave this talk at, I think it was Bay Threat, one of the guys stood up and was like, I did QA on that game like 10 years ago. I'm like, holy crap, you're old. All right. So data residence, this is knowing where your data is. Remember how I said in your data center, you could point to a server and say, there's my data. That becomes very hard in the cloud, the big generic cloud. The reason you want to know where your data resides is if you're ever called as an expert witness, or if you're performing an investigation and need to really back up your claim, add some validity. Being able to point to where the data is really goes a long way. Like if you're investigating a murder and say, hey, there's some blood right here. Where's it from? I don't know, but there's blood right here. That's only so good. You just know that you have some blood. You can't really attribute it to anyone or anything. So it's all about credibility. Now, this becomes difficult in cloud, and well, the cloud providers know it, and I don't want to say they dance around it, but they kind of dance around it. Amazon, right at the bottom, your objects are redundantly stored on multiple devices across multiple facilities. Sounds great, right? From a data redundancy, resiliency standpoint. Can you point to a single place where that data resides? If they tell you something like this, it could be anywhere. Azure, this is probably my favorite. It's the most cleverly worded one. Microsoft may transfer customer data within a major geographic region. Example, within Europe. And it'll replicate between 2 subregions within the same major region for enhanced data durability. If you told me that I was going to buy a laptop and it was durable, I'd be like, yeah, hell yeah, that's great. I want a durable laptop. That's fantastic. But it's kind of sugarcoating the fact that they're saying, hey, we're going to kind of pepper your data over here and a little bit over here. And, if it's in Europe, who here is European? Anyone? The data privacy rules in Europe, crazy restrictive. And I've heard from people, if you want to run a data center or serve applications or a service to Germany, it's just easier to set up a data center in Germany because it's hell to try and get all the regulations. Same thing if you want to deal with Italy. Far more concerned about privacy, individual privacy, than they are with compliance and security. I think it actually goes, so security's in the middle, compliance on the bottom, and then privacy on top. What about Google? Everyone loves Google. At this time, selection of data center will make no guarantee that project data at rest is kept only in that region. Well, that doesn't really help me out for my investigation. Where is the data? It could be anywhere. We're not really sure yet. We'll tell you later. Now, what if you're using multiple clouds? So this is the hybrid model, or just multi-region model. So if you want to spin up a cloud instance in Europe, you might not want to go with Amazon because maybe it's more expensive than a local cloud provider. So you want to be able to have data kind of synced all over the world with multiple cloud providers. Can you point to where your single piece of data is? Highly unlikely. So catching clouds is extremely hard work, but trying to pick a specific cloud is really hard. Does anyone want me to leave it on this slide for a bit, or so you can find Waldo? Where? Yeah, the guy with the hat. He's right there. So we don't know where our data is. That's not so great. Now what about physically acquiring the data? This is what we always used to say. Unless you can tangibly acquire that data by having a disk in your hand, it's not useless to you, but it's of less use. And, of less use than just having live volatile information or logical information, a logical capture of the information. Well, who here wants to be the guy the person who calls up Amazon and said, hey, can you send me the hard drive that my cloud instance is on? Because I really, I need to do this for forensics. I'd like to see how high up the rung that call gets past the front line. So unless you're like a Fortune 2 company, they're probably not going to help you that much. You're CSP in that respect. So we're probably going to be stuck taking snapshots or just relying on logical imaging, which breaks a lot of the rules that we, as forensic practitioners, were told, we don't want to do that. We need we need that physical drive in hand. I've got a great anecdote. So I'll tell this anecdote now. I used to work at a university in Western Canada. When I did quite a few investigations of child exploitation, distribution of illicit files. And it was not uncommon for someone to wheel down a pallet of workstations and saying, okay, we had someone say that they caught someone distributing child pornography, and we suspect that he was on one of these like 20 systems. Great. Attribution, it's one of these 20. So, I'd get the drives, I'd image everything, I'd put them on my investigative drives, I'd sign the chain of custody forms, I'd hand them over to my boss, and then I'd wait in case I needed to be called as a witness to testify against the defendant, or the accused. Well, I left before the case came to court, and the police, actually the Crown prosecutor, called me saying, you don't happen to know where those hard drives are, do you? No, I don't work there anymore. Oh, well, your chain of custody form says you handed them over to your boss, and he doesn't really know where they are. I'm like, well, I can't really help you. So not only could I not point to the data, but the company that was trying to prosecute this guy couldn't point to the data. Luckily, he decided to defend himself and was batshit crazy. So it all kind of worked out in the end, and he admitted to everything. I can tell you the full story over a beer sometime. So image acquisition. I'll stick with Amazon because people are most familiar with Amazon when we're talking about cloud instances. And from what I've seen, they're probably the best at giving you information on how to actually get some of that information out for forensic uses. So these are the three ways that I know of. There's the snapshot of the EBS volume. There's the have AWS actually ship you the data. So I was kind of tongue-in-cheek joking about that. They're not going to send you the physical drive. They will send you a physical drive. Then there's this thing that I kind of stumbled on probably about 2 months ago, where there's AMI tools that you can use, and APIs to actually move this data around and get it to you. So this may, yes? Like, would I recommend one over the other? I'll show you some stats in a minute. It all depends how expedited the request is. So I found this online. I was searching, I'm like, there's gotta be a way to just, kind of emulate what I'm used to doing in a Linux environment. So I found this post. You launch a clean Linux Amazon machine image instance, stop the instance of the suspect system that you want to inspect, detach the volume, dev SDA1, create a snapshot of that now detached image, attach your dev SDA volume to the new AMI, but don't mount it. You got that, Craig? create a new EBS. No. whenever you're ready. All right. Create a new EBS volume the same size, because it has to match. Attach the new volume, then use these commands here. So you're making a file system, making a directory, you're mounting that volume, you're changing ownership to the EC2 user, which is the default user, and I will provide all these slides, so don't feel like you have to write furiously. And then use DD to make an image. Pretty simple, right? What could go wrong? I was amazed that this actually came from Lance at AWS. So this was someone in Amazon who said, hey, you know, this is what I found to work when someone asked me. I'm going to post this out. So he was helping out Albatross Digital. I understand your need correctly. I would consider using DD to make an image of the EBS volume, i.e. dev SDA1 you wish to capture, and then that list of operations. Very helpful. Thanks Lance at AWS. The problem is this isn't signed. It's not encrypted. You can't really prove chain of custody other than writing in a notebook your steps along the way, which may be admissible. It might be enough depending on how good your lawyer is, how bad their lawyer is, or if someone can just cop to the investigation. I've got all sorts of stories. I know a bunch of guys that were in the was it AFOSI, the Air Force Investigations Unit, where they just hire, or they just bring in this grizzly old guy who kind of sounded like Sam Elliott, and he'd just drag the guy into the room and he'd confess in tears, so it was just easier than doing a whole investigation. So here's the preferred AWS method. So Amazon has a service where they will take data from the S3, which is their big storage blob that you can put data in. You ship them a USB device that will contain your data. They will, so it's $80 per storage device handled plus $249 per data loading hour. So obviously, if you use like a crappy old IDE drive and a USB 1.0 connector, you're going to be paying through the roof. I think the best method is, I think you can get away with iSCSI or just like a really fast serial ATA, but it's, it's still going to cost you quite a bit. The problem, though, it's impossible to verify the integrity of the disk image, and that's direct from a paper. There's a researcher, or two researchers, Dykstra and Sherman, that I quote quite a bit in this, and they've done a lot of timing and evaluation of the different forensic methods of the cloud. Then I stumbled upon this thing, which is kind of cool. Not only, so these are tools that you can download. You can create a volume bundle, and it will compress it, encrypt it, and sign it. Hey, chain of custody, I can now prove that Amazon has done this process for me by running these tools. This is a lot better than just kind of making it happen myself. You can migrate it from one region to the other. So if you're imaging a system in, Virginia, the AWS region in Virginia, but you're in California somewhere, or Oregon, you can move it so that it's closer, make download a little bit faster, and then you can just call the download. So you can download that bundle to your local storage and perform forensics locally. Hey, this to me seems like the closest way to emulate manual forensics or traditional forensics. So this is the experiment by Dykstra and Sherman, where they took the next slides are going to blow up the graphic on the bottom. So they did a manual installation of Encase and the FTK agent. So FTK, great for grabbing and imaging. They used VM Introspection, which I'll get to in a minute. Or they used the AWS export process where they ship the drive. So here's the closer look. So experiment 1. And you'll notice that all of these were successful. Their attempts to get the information off. On the far right-hand side, we have the time it takes. So you were asking, which is the best method? Well, for the physical image, or the closest thing to a physical image, it would be the AWS export where they would send you the drive. But if this is a really time-sensitive issue, can you really just, I submitted my request. I'll just wait the 120 hours and hopefully it'll get there. And if, I'm pretty sure they use like FedEx or UPS and they just kind of leave it with, that's not really chain of custody in my mind. But Encase, FTK, Imager, Fast Dump. So the first three, we're talking 12 hours. The other one, so Memorize is for memory acquisition. So we're doing live analysis, 2 hours. Volume block copy, 14 hours. Agent injection. So VMware Introspection is probably one of the scariest terms that anyone who thinks about cloud will ever hear. So VM introspection is the subverting of the virtualization kernel and doing all sorts of things that the user can't see. So this is really old. This came about in the times of IDS and IPS when people were still theoretically talking about doing this kind of thing. So introspection from a forensic analysis perspective, fantastic. From a privacy perspective, scares the hell out of me. I don't want people looking at this. Luckily, for VM introspection, your provider has to go out of their way to enable it. Of course, chain of custody for that's a whole other, or proof of that is an entirely different thing as well. So let's talk about what was required to do this. So if you look at the bottom, AWS technician, technician host, hardware and software, AWS hardware, AWS software. There's a lot of moving pieces and a lot of human elements to this, plus time. So it's entirely up to you which way you want to go. Personally, I really like the AMI tools. I think those tools work pretty good. Oh, of course, I talked about introspection. So yeah, Garfinkel and Rosenblum. Virtual machine introspection-based architecture for intrusion detection is the name of the academic paper, which sounds very academic. And it, like I said, you can subvert the hypervisor and look at pretty much anything on the system. You can look at, tell me, why would this be good from an incident responder or forensic analysis perspective? Mark? So if you had an encrypted volume and someone's working on that decrypt and the volume's decrypted, if you're using VMware or hypervisor introspection, you don't have to worry about keys because you have direct access to the unencrypted drive. That's forensic gold mine there. You don't have to worry about trying to crack the keys. You just have access to the data. That's awesome. But again, as a user, scary. And introspection has to be enabled by the provider, hard to prove integrity. So if you're getting the information through hypervisor introspection, it's very hard to prove the integrity of that information that you got, with the exception of meticulous notes. So that's one thing they always drill into you if you ever do any sort of forensics training, is that you have to keep meticulous notes, preferably in written form, just because you don't want to really type it out all the time, because you're doing computer investigations, writing it on another computer. You're not going to be able to bring your laptop up with you when you take the stand, but you can bring a notebook. So this is one thing. So does anyone here do like malware analysis or respond to incidents involving breaches or active attacks? Yeah, some. So one of the things they tell you in forensics is don't go kick the plug, because it will kill all interaction with the server. In cloud environments, we're not telling you to kick the plug, but we're telling you to put the shields up and move it off. In traditional forensics, that's not something we would do. We would say, okay, leave the machine state as close to pristine as possible and image it in that state so you know what's going on. But in cloud, you don't have that physical access to control the adjacent networking configurations because it's the internet. So you have to isolate so that no further damage or tampering can happen. And this really comes to, down to blocking incoming, outgoing, and being able to point to where that instance is. And that might have to be, okay, this is the IP address, and this is the region that the cloud service provider says my instance is in. That might be the extent to which you can put your finger on the location. So you also have to, when you're isolating, collection, you have to be able to collect from it. So it's not just put the shields up, put it over to the side. You still have to have access to that to get at the information. You have to make sure that you're not contaminating. Everyone's heard of the, well, I guess it's an adage of too many cooks in the kitchen or too many fingers in the pot. The worst thing you can do is have like 6 people say, hey, let's all investigate this incident together, independently. Bad idea. Everyone's stepping on everyone's toes. You have someone to coordinate and tell people where to look. Separation, you need to distinguish what is part of the incident and what is not. So if you can identify, this is where application whitelisting is so powerful in incident response and forensic activities, because you know what you don't need to look at. You just need to look at what has changed or what differs from your expected result. File integrity monitoring, also big piece here. And then this is what people always think of when they're told, okay, well, I'm going to go talk to my cloud service provider and they're going to help me. It becomes a lot of finger pointing, and this is probably the best rock, paper, scissors image I've ever found. And it's quite indicative of reaching out to a cloud provider to say, hey, can you help me with this? Some will say, yes, we'll hand you over to our incident group. Some will say, well, we can't really help you because we're small, we don't know. Launch a new image, hope for the best. So a lot of providers do have people that can help. I know a lot of the best forensics people that I know work for a cloud provider or a company that has some real estate that happens to be a cloud provider, such as Google, Amazon, Rackspace, Terramark. One thing that you really want is contracts. This is where paper comes in handy. You need, when you're going and evaluating a cloud service provider, you need to know what they're going to do and what you have to do. How far are they going to go down to help you, and what mess are you going to have to clean up once they stop? These 4 items on the bottom, I would definitely ask for samples, examples of past investigations. Even if they're sanitized, you'll understand their thought process and their workflow. And their methodologies that they've employed. Credentials of staff. Anyone can say that they're a forensic examiner. A bunch of people fresh out of school, tech support agents that have some Linux skills. Hey, I do forensics now. I want to see credentials that say, if I come to you, I'm a Fortune 500 company, I want to know that the person on the other end can help me and will understand and can speak my language from a technical perspective to help me do this. And if they'll let you, interview the team members that do the incident response. That's a big win in my book. Obviously, the higher up the fortune list you go, the more likely that part's going to happen. And it also depends how much money your company is worth to them. So legal issues. I am Canadian. Your laws do not really apply to me as much as you might think. Our lawyers wear funny wigs. Our Supreme Court justices dress like Santa. And you probably just don't want legal advice from me. So I don't think I can make it any more clear that I'm not a lawyer. This does not constitute legal advice. So there are legal issues with cloud, such as the expectation of privacy. And these are really applicable for both premise and cloud that you need to consider when you're talking about forensics. Possession, custody, control. This is where chain of custody comes in. Who is handling the data? Who did you hand it off to? Where is it being stored? How many people have access to it? Who has a key to the room? Preservation. Are you putting it in a safe? Is it just being locked in your drawer? These are all things to bring up with your legal team. Jurisdiction really comes into play. Now, as a Canadian, based on my knowledge of law through watching Law and Order for most of my adult life, there are jurisdiction issues when you cross from New York to Massachusetts to California, and there's all sorts of issues along that with data in one place versus the other. It gets even worse when you start talking about other geographies. Like I was saying, Germany, Italy, very sensitive. The UK as well. And then seizing of data. So, well, no one's going to see this from that company. So I used to work at a bank in Bermuda, and we did a forensic exercise where we found out that one of the call center people were doing, they were downloading mass amounts of data while they were working to a USB drive. Now, what they did is they tapped me on the shoulder one morning and said, okay, this guy's in a meeting. I need you to go take his system and image it. All right, so I did that. Put the system back. He didn't know any better. He was on training for a bit. Then I just did the imaging. They didn't ask me to do any investigation at all. So I handed it off to my boss, made him fill out the form. My bases were covered. Then I was told that we didn't really need to do any investigation. Why? Oh, well, the local police here in Bermuda have gotten involved. Okay, well, what does that mean? Well, so we don't really need the data. We'll hang on to it for now, but they went into his house, they confiscated all his computing equipment, he's been summarily dismissed, and he's being brought up on charges. Like, holy crap, that's like, you know, when you watch Law & Order, that's that hour, or that CSI 1 hour period, you know, judge, jury, executioner, done, he's out of here. Never seen that happen anywhere else. So, good. Now, it's really not all doom and gloom. This is a fantastic quote that I found last week, where cloud forensics tools need to be a hybrid of static and live collection and analysis methods. And they really do. We need to evolve our processes and our tools. But, you know, and this image just popped into my mind, especially the last part of the statement, you know, predict artifacts based on forensic heuristics. That sounds tangible. So a lot of the old tools will work, just not in the same way that you're used to having them work. The biggest challenge in terms of wrapping your head around doing forensics in cloud environments is changing the way you think about acquiring information. So, you know, you're not always going to have the images on site. You have to think about having them off site, like in the cloud. You may have to process them off site, like in the cloud. And you may have to do your analysis and the launching of your tools off site in, you guessed it, the cloud. So for a lot of people, it's not this easy. This is one of those trust exercises. Obviously, a man of my size has never done one of these and probably never will, for legal reasons. So it's not this easy. Yeah, this is probably more like it. It's not this easy either. It's kind of like this, and you really hope it's not like this, or this, or this. So you do have to put a little bit of trust in your abilities as a forensics practitioner and incident responder, and of the abilities and capabilities of your provider in order to help you get things done. So this is something that I thought was really cool. Has anyone seen this Nbd Server Utility before? So what it does is it creates a read-only network block device. So traditional forensics, where you have a physical drive, you usually have, and I can't remember the name of the company, but it's a little, seemingly, it looks like a USB or a hub, like a 10100 hub, and you plug the hard drive into one end, and then you plug your forensic hard drive into the other. And it's a write blocker, so it only allows you to copy data off your suspect hard drive, which is great because you will never contaminate it with this write blocker. In cloud, you don't really have this capability, but this kind of allows you to emulate that. So you can also use volatility, which is used for analyzing memory, and this is where you get it. Again, don't write it down. I'll give you the slides in a minute. So this is my conversation. I'd like to thank Ken Pryor, Katie Pryor. He's really good to follow on Twitter. He's a police officer in Ohio, I believe, and he kind of helps out on forensics when he can. Not his full-time job, but very smart, very approachable. There's his blog on the bottom. So I was going to do a demo. It didn't really work out that well. Hotel Wireless isn't great for downloading ISOs and setting up servers, and I had some problems, and I messaged him, like, so I was trying to compile the client Server installation, no problem. Client, not so great. Whoever built this tool requires glibc version 2.28 or higher. Does anyone know what version on typical Linux distros are these days? Like Ubuntu, CentOS? It's 2.15. So there's not really much you can do. It's hard to just, upgrade glibc. He's like, oh yeah, I use Kali Linux, which is like the new, what's it called? Backtrack. Yeah, the new Backtrack. So I tried downloading that, and when it told me that it would take 4 days to download on Hotel Wireless, we abandoned this whole notion of a demo. And this is me complaining, and apparently it's not that Ubuntu hates me, it's just slightly, it hates this person slightly less than CentOS. So yeah, I was pretty upset when I was doing that. But here's how you use the tool if you can get the damn thing installed. So you run the server, -C for the connecting IP address. So this is the IP address of the client, and this is the drive that you want. And this is for read-only. On your client, block device for the mod probe, then execute the NBD client to the server you want to connect to, the port, and then the block device that you want to connect to. So this tells the client, there's the IP, use port 60,000, and create the new network block device locally here. You can then run FLS. Anyone know what FLS is? It's for timeline creation to see what has happened or what's transpired on the image. It comes in the sleuth kit. It's great. So this is just running, file format NTFS. You're looking for the C drive because that's kind of what you shared up there, and then you're putting it to the test.fls. If you don't want to do all this, and you don't want to fight with compiling it, you can buy fresponse. They're probably at the forefront of doing cloud imaging and data capture because a lot of their customers, so these guys specialize just in acquisition. They're not a big forensic analysis tool. They just want to get you the data. So if you can see on the bottom here, they have connectors for Amazon, Rackspace, OpenStack, Windows Azure. You can also do Gmail, connect to Gmail, I think Office 365, and start indexing that information. So this is Chad Tilbury, who does a lot of stuff with SANS, and very smart forensics person. He did a blog post. The blog post is at the bottom, but the idea behind fresponse is so simple and elegant, it's hard to not punish yourself for not thinking of it. Using the iSCSI protocol to provide read-only mounting of remote devices opens up a wealth of options for those of us working in geographically dispersed environments. Remote imaging to fast forensic triage to live memory analysis. These are things that he's done and he's tested using this tool, relatively inexpensive tool. So pretty cool. But one thing I wanted to highlight, anyone here a developer? I've got a project for you. It's using iSCSI. Windows 2008 R2 and later has built-in iSCSI capabilities. If you wrote a client that can mount the drive using iSCSI, you wouldn't have to use this or buy this tool. You could have native mounting. So go home and read up on how to do that, because I'm not a developer. There's new tools popping up. Now this is one that I have very high hopes for. It's developed by a lot of really smart people, most of which work for Google. It's the GRR, I can't remember what the GRR stands for, but it's a response framework for doing live forensics. So it's really built for cloud to kind of take a whole bunch of, 5 minutes, jeez, a whole bunch of images, or a whole bunch of systems, image them, kind of pull everything back and do distillation. So think of it as like a SIM or log management tool, but for forensic images. So you're kind of distilling everything. So you can get it on GitHub, Google Code, because they all work at Google, and test it out. There's an excellent paper or presentation on the rapid response, GRR rapid response, if you want to No one wants to scan my QR code in my presentation at a security conference. I'm shocked. So there's the link if you want to grab it. But it's a very thorough explanation of what the tool is supposed to be, what they started with, what it needs to evolve to, and the people involved. So again, if you want to get into forensics, this is actually a really good place to be because you can get in on the ground floor and see the inner workings of how to do this stuff in cloud environments. So there's a lot of evolution that needs to keep happening with tools. So I'm going to zip through some of the, so I used to be a product manager. So I'm very good at saying, hey, look at this great big idea. You guys should go build this. Because I'm not a developer. Because everything's easy on paper. Developers tell me that that's not always the case, but I don't believe them. I just need to know when it's going to be done. So these are some of the ideas that I have for forensics. So automated instance isolation. So instead of having to go in, change your firewall rules, put it off in the corner, have it happen immediately. I'll just zip through this because we're going. So automated instance isolation. So we've got a server. We determine either through logs or some other type of inspection on that system, third-party tool, that something malicious has happened. We panic and we decide, okay, well, we're going to log in and we're going to put that new firewall rule policy that blocks everyone out. Except when we're ready to investigate, we're going to open up the firewall so that we can let our incident responder poke in, take a look, and start doing the analysis while blocking additional communications from anyone else. So this really isolates the server. I'll give you a hint. If you want to build this, the Amazon API, you can do this all through the API. It's just, not a developer, don't have time. Forensic workbenches. All right, so we want to spin up, we have a private cloud instance. We have public cloud servers. Public server gets compromised. We can just spin up our workbench so we don't have to build back to our incident response or the security team to have this server running 24/7 because, incidents only happen once every 10 years, so we're okay. So we just spin it up dynamically. Now what about automated so timeline generation? We didn't talk a lot about timeline generation. I showed you the FLS command. What it does is it literally gives you a timeline of events. So this process was executed, and then this stuff happened, and then this user typed this in, and then this stuff happened. So it's recreating the crime scene for you. So wouldn't it be great if you didn't have to do that manually and execute the commands? So you could do automated timeline generation across every server, not just the ones that are compromised, but the ones that you know are good, and you can then compare them, and then distill them, and then bring them back, and then store them locally for the next time, so that your process is that much faster. Or if you wanted to keep them in the cloud, so you're not pulling down all these different types of timelines, you could just have a local data store, and then copy the local data store distillation file down for analysis, and then back it up. Now what happens if we're doing, has anyone ever responded to an incident or done anything security when just bang, the power goes out, or something catastrophic happens like the network goes down? That makes it very hard to keep doing what you're supposed to be doing. So if we have a whole bunch of cases that we have to analyze, and if you're 10 minutes left, awesome. If we have to do a whole bunch of cases, so I have a friend who's a New York City detective, and I asked him how many cases he handles on average. He stood up, and he's a little bit shorter than me. He said, I've got hard drives on my desk stacked this high, and I just grab from the top, unless someone higher ranked than me comes and tells me to take one from somewhere else in that rank. All right, so wouldn't it be cool is if you had all of this work to be done, that you could just spin up extra working servers to start crunching through this data and generating timeline, ripping out artifacts, and I'll talk about artifacts in a second. Just doing all these forensic processes in parallel. This is where cloud excels, all of these dynamic workload instances to get something done really quick and then shut them down when you're not using them. So you don't have to So I don't know if you guys know this, but budgets for police departments, they're hard to come by. And forensics, you're really told to make do. You get deep discounts for the tools if you're in law enforcement, but sometimes, that money goes to training, and then the next year it goes to upgrading the tool, but no training. So you're kind of fighting for budget with everyone else in your department, or at least in that little region. So, if you can do this on the cheap and still maintain the integrity across all of your data, then that's a big win, especially for law enforcement. So you can dynamically spin things up. Now, file carving, just like it sounds. You are taking an image and you're ripping out pieces of interest. This is really important in child exploitation cases because what are they distributing? Movies, graphic files, documents, MP3 files. So if you could do distributed file carving, you could send this work out to multiple systems and they could be responsible just for ripping out those types of files. And to give you an idea, a lot of this information is stored in the first 20 or so hex characters of the file. So you'll know if it's a JPEG or an Excel file, or there's obviously ways to, 20 minutes left, awesome. So with that, multi-cloud analysis servers, again, same sort of thing. If one of them goes down, you can keep doing your work, and as soon as that region comes back up, anyone here have Netflix? Yeah, isn't it awesome when US East goes down? You can't watch your Yo Gabba Gabba or whatever it is. So just to summarize, this is some information that I really hope you'll read. The NIST publication, like I said, if you want to get started in forensics, great place to start. There is a NIST Cloud Computing Forensic Science Working Group. Right now it's about as exciting as the title sounds. I'm definitely the dumbest person on that working group because everyone else has a PhD and they're talking about stuff that I would have no idea what they're talking about unless they described it. They dumbed it down for me. There's also this site here, the Cloud Forensics Bibliography. This person, and I'm not even sure who it is, lists all the papers they can find on cloud forensics. So they just put all the references there. It's a wealth of information. And then I'm going to be committing code. Even though I said I'm not a developer, I script a little bit here and there. So I'm just going to be putting all my stuff up on GitHub. This presentation is up there already, so you can grab it from here. And quickly to summarize, you need to have an open mind about the old ways of forensics. You need to think more about having only logical access and making do with that. The cloud, as I've shown with some of those big examples of tools that don't exist yet that should exist, you can really harness the power of cloud to do these things much faster and easier than you could with traditional servers and applications. And the tools need to evolve for these dynamic environments. If one of your regions goes down and it comes back up, it needs to know where things left off so it can join back into that grid and keep on going. And with that, are there any questions at all? Let me get water first. No questions? No? Everyone wants to go home? Okay, well, if you ever want to reach me, Andrew SM Hay on Twitter, or send me an email. Thanks for attending. Oh, I really hope that wasn't busy.